Africa needs high-performance computing because we need to start doing research on African-focused problems. A lot of the research is done in Europe and America and may not be relevant, so we need to start doing research for our own problems.
The CSIR-hosted Centre for High-Performance Computing has a project called HPC Ecosystems. That program or project sees decommissioned HPC hardware distributed to research institutions, universities, and other places of interest that would get great benefit from the decommissioned hardware. The decommissioned hardware comes from various different places, some from the Square Kilometer Array project, some from in-house at the CSIR, some from other high-performance institutions across the world, in the Americas, Europe as well. This happens all over Africa because we'd like to democratize access to high-performance computing. The other big thing is we're giving them access to AI, which is a big topic across the world. So now we are able to be a big player in that open field. We can come up with our own models tailored to us and our problems. We can now solve our own problems specific to us.
A typical supercomputer is composed of a lot of computers. So you have your typical laptop. How a supercomputer differs, they have things called nodes, which is equivalent to your computer, except it has 2 processing units instead of 1. And you take about, in our case, we have 25 of these computers, and then you slot them into the cluster is what we call it. And so these 16 computers together become a supercomputer or a cluster.
The hardware we've received will really further what we can do as a group. It's hardware that's much more competitive, much more recent, much more representative of what is in the real world. So it allows our students to have a real background and really foster their education in high-performance computing and competitions to be more competitive within South Africa and South Africa competing internationally.
It's been great participating in these competitions because we get to work with these supercomputers that we wouldn't have access to otherwise. The protein folding example was exciting for me because it was the first time I saw my visualization at one of these competitions, and it was very eye-opening to see all the work that went into just a simple video clip of the protein folding.
Often at these competitions, we do weather simulations. These simulations are important for climate change, weather prediction, and storm prediction, early warnings, and many such applications. In these simulations, you're able to predict heat waves, storms, rain, different pressures in certain areas, and all these are then combined to provide not only visuals, but also data to predict natural disasters. The systems that these are often run on are extremely large and extremely complicated, and the goal is to take that weather simulations and simplify it down to where it can run on a smaller machine, more locally, and more distributed.
Through the collaboration with the CSIR, we've been able to publish 2 papers about how the group works and how we use decommissioned hardware. And the current hardware we do work with was also a decommissioned system we received. And we use that hardware to train other students for competitions they've participated in.
The collaboration with the CSIR, the Ecosystems Project, and the CHPC is the backbone of our group. It's the reason we can exist and the reason we can do the teaching and the competitions we do. The resources we have from them is what we use to teach, to train, to learn. It allowed us to build a little ecosystem with inverts for us. So without it, this would not happen.
I'm really looking forward to see Africa's young people tackle these complex problems with great solutions ideas that are homemade and generated here at home.